Hello aviators! Today our lesson is on airplane flight controls. We will be discussing the three primary flight controls, the ailerons, the elevator, and the rudder, and then also secondary flight controls such as flaps and trim systems. Before we look at the various flight controls, let us familiarize ourselves with the airplane's three axes of rotation. As you can see from this diagram, the airplane will roll upon its longitudinal axis. This is accomplished with the use of the ailerons. The airplane will pitch upon its lateral axis. This is accomplished with the elevator or the stabilator. And finally, the airplane will yaw upon its vertical axis. And this is accomplished with the rudder. Now we'll take a look at how we operate these controls in the airplane. We are sitting in a Cessna 172 on runway 29 at the Merritt Island Airport. The first flight control we will discuss are the ailerons. Remember, this is the control that will roll us about the longitudinal axis. To roll the left wing down and the right wing up, the yoke will be turned to the left. And to the opposite for right wing down, left wing up. You can see from this outside view how controlling the yoke will move the ailerons on the outside of each wing. As I move the yoke to the left, you can see that my left aileron will go up, which forces the left wing down. My right aileron goes down, which forces the right wing up. And reverse when I give it right yoke. Next, we'll look at the elevator or the stabilator. This is the flight control used to pitch the airplane about its lateral axis. To pitch the nose of the airplane up, the yoke will be pulled back. To pitch down, the yoke will be pushed forward. The Cessna 172 has an elevator. If a plane has a stabilator, this entire area will move up and down. But as you can see on the 172, it is split. When it's split like that, it's called an elevator versus a stabilator. So pulling back on the yoke causes the elevator to be raised, which puts downward pressure on the tail. If the tail goes down, then the nose will rise. Pushing forward on the yoke does the opposite, causing the tail to rise and the nose to drop. And finally, we have the rudder, and that is controlled by our foot pedals. As you can see, pushing the left pedal will give me a left yaw about the vertical axis, and a right pedal for a right yaw. Let's see what this looks like outside. Left pedal moves the rudder to the left, which actually causes the tail to move to the right. Then the nose, of course, would go the opposite to the left, and then opposite for the right pedal. You can see the rudder moves to the right, which would force the tail to the left, in turn causing the nose to move to the right. Now you will use the rudder pedals to turn the airplane on the ground, not the yoke. However, in the air, the rudder is not the primary flight control used to turn. It will be used in the turns, but it is not the primary flight control. More on that later. Right now, let's get this thing in the air and see how it looks. Okay, aviators, here we are, level at about 1,500 feet, heading in a southerly direction down the intercoastal. If I want to move the yoke to the left, that's going to cause me to roll upon our longitudinal axis, and vice versa if I go to the right. So let's see how this looks outside the aircraft. If I give it a left yoke, get into a left roll, right yoke, right roll. Now notice the airplane is also turning direction. So in the air, our primary means of turning the aircraft will be the ailerons. However, and we'll discuss more of this later, we have to coordinate the turn with our rudder pedal. Now, if I pull back on the yoke, we'll go into a climb. You can see our vertical speed indicator there, and our altimeter is increasing. And if I push forward on it, we will go into a dive, we'll lower the nose, and we will start to descend. And from the outside, we can see how that works. I'm pulling back on the yoke. You can see my elevator on the tail there moving down, up, and finally our rudder pedal. If I give it a left pedal, you can see that it starts to go into a yaw, and the plane turns a little bit, but not a whole lot. And same thing with the right pedal. You can see the airplane's not real stable when you control it just with the rudder. You have to coordinate the turn with the ailerons, and again, we'll discuss more of that later. Now, two more controls we want to talk about today. These are secondary flight controls. One is the trim. Now you can see that is right down here, this wheel, and unfortunately it's not working on this simulator, but if I move this wheel, the trim will take effect. And what the design is, you can see here that on our vertical speed indicator that the plane is not flying level. In fact, it's starting to climb, so I would have to put a little forward pressure on this yoke to keep us at zero vertical speed if I wanted to stay at a constant altitude. So what I can do is I can use the trim button, and that will adjust the yoke a little bit so that I don't have to put that pressure on, either forward or back, whatever it might be. The last flight control we will discuss today are the flaps. They are attached to the trailing edge of the wing and are used during approach and landing to increase wing lift. This allows an increase in the angle of descent without increasing airspeed. So if I activate the flap control, you can see the inside portion of the back part of the wing goes down. Usually there will be 2 or 3 settings of the flaps depending on the actual airplane, and depending on wind conditions and humidity and temperature and all of that, turbulence, I will determine how much of a flap setting that you will use. On this particular airplane, the flap control is down next to the passenger side yoke. You can see it right here. So if I push them down, you can just barely see that behind the yoke, how that controls the flaps. So this concludes our lesson on flight controls. Fly safe.